Okay, well, I'll just stand over here. Okay, well, thank you, everyone. My talk today is really going to be about a bit of reflection on where we're coming from in this machine learning and AI space, and where I hope we'll be headed over the next, 5 to 10 years. Is there a clicker that makes the slide go forward? So, thank you very much. I think to draw a parallel with where we are, it's instructive to compare us to another technology that's actually prevalent in our everyday life. It's actually steam power, whether or not you realize it. And that's something that was kind of invented about 2,000 years ago when a guy called Qirong from Alexandria, he made this cute little thing here. I don't know if the video plays. I guess didn't work with the Mac over here, so that's okay. You have to imagine that this thing is spinning round and round. And it turns out that this thing, which was, you could almost consider a toy, it works sometimes. And in terms of practical applications, I'm happy to say that 2,000 years after this was invented, the only application it's ever been used for is your kid's science project in high school. Now, about 1,700 years later, people made the first serious attempts to scale up the use of steam in industry. And this was about Isaac Newton's time, so the engineering and physics principles were fairly simple, but people had a lot of enthusiasm. They built these very large contraptions that were big, bulky, pretty much limited power. And it turns out that every one of these things they built it for a very specific application, the most popular of which was pumping water out of mines, pumping water out of rivers, basically. So it was kind of a period of time where people were engineering, maybe almost over-engineering some of their solutions to do one thing and do it very well, but every time they needed to do another problem, some of which hadn't been invented yet, they just basically started all over again, pieced together another contraption that looked something like this, but it's completely different. So it took about 100 or so years before the first truly standard steam engine was invented. That was called Cottage engine. It was very carefully and very intentionally engineered for multi-purpose use, and because of that, it was actually universal. It was actually able to plug into multiple industries which had seemingly no relation to each other, from agriculture, metallurgy and metalworking, textiles, ships, transportation, trains. And part of the key to that was that it was, in addition to, of course, being fast and efficient and powerful, it was easy to maintain. It kind of operated under any workload. And so it became the first truly universal steam engine in the world. It crossed multiple industries. It brought together industries that we had no idea had any connection before that. And today, I want to mention that steam power lives on today in modern steam turbine. It's pretty much an indispensable part of industry. It's powerful. It's pretty much standard. There's only a few companies in the world that make these things. And you can transport them anywhere from one factory to another. You can install them anywhere, in any factory, power plant, ship, robust and maintainable. It's completely worry-free. And apologize for the formatting here. It's completely worry-free. You install, you basically forget that. So I wanted to use these 4 reference points to kind of ignite a bit of discussion about where we are along the industrialization of machine learning, industrialization of AI. If you were to ask me where that stands right now, I think we could probably agree that a lot of solutions are still more or less being handcrafted by experts. Some of those solutions make it into great business ideas, and you make a startup around that, or you make a product around that. And for a lot of other solutions that aren't at that level of maturity, you basically install this thing, and then you keep manually tuning it. So there's this old joke that goes in the deep learning community that you've got a deep neural network, so it's not working. You hand it over to your favorite professor, he makes it start working, he hands it back to you, it stops working. So, well, you've got bundled then some kind of data scientist or machine learning engineer with the product. In fact, speaking of bundling machine learning engineers with product, I'm from Petuum, so I sit in Uber self-driving cars all the time. They go even further. They bundle 2 engineers for self-driving cars. Fantastic. I'm not kidding. They really have 2 engineers per car. So, there's really no standard product seen across industries today. I mean, we all have our favorite solutions in certain areas, like especially in the technology sector, and there's a certain set of solutions we converge into. You go a little bit further, manufacturing, utilities, telecoms, fintech. People don't have a standard answer. Sometimes they don't even know what problems they're talking about, and that really leads to another question. What's the realistic expectations of AI? What are the realistic expectations that people, say outside the Bay Area, outside the technology industry have? If I were to venture a guess, I'd say we're probably here in terms of development. We're at a point where people are building these single applications. They're doing a pretty good job of it. We're not yet at the point where we're starting to see truly standard products penetrate any part of the market, let alone even make many of the other industries aware that you can have a standard product. There's a very standard way to use these things. And speaking of realistic expectations, do we expect things to go the same way most technologies have gone in the past, to increasing standardization, to increasing transportability, increasing the ability to just put it anywhere and run? Or sometimes we might see the media might fuel the speculation with dreams that anything is possible in AI, and then your imagination goes kind of wild. And I think that sometimes contributes a little bit to the difficulty of making expectations line up between AI and machine learning solutions versus what most industries expect out of them. And I wanted to talk a little bit about what one of the pain points is, and one of the reasons why we're at that level of standardization that's like Newton's time versus the Industrial Revolution time in 1850. I think most of us, when we try to go and build an artificial intelligence solution, we have the data and task. We probably have some kind of platform and hardware already in place. That's maybe that's provided by the corporation, maybe that's provided by your university professor, whatever setting you're in. Maybe you're using cloud compute for that. And if you want to make a solution, you basically, I'm sorry, my animation isn't playing right here, so you have to, excuse me while I find the laser pointer. Right, so you take data, whatever data that your industry or your solution demands, you connect it to some kind of task, be it self-driving, automatic piloting, financial analysis, healthcare, and then you're going to draw some line, picking some model, some algorithm, some maybe open source implementation of it, some open source system, and connect it to the hardware you have. Now, if you want to do another solution, you basically draw a different line through that. Then some businesses try to automate some parts of this by selling that as a standardized component. But what I think we're not seeing is a product that really covers this entire space, which is the space that most folks in the world don't need to know or don't need to care about. They don't need to care about the data, the task, and whatever hardware they have available they're going to buy. And I think what we're seeing is that much of what's in this space is usually narrow, highly specialized technology. When I say that, I don't mean it's not powerful, but that requires a lot of expertise. You might generally need a machine learning engineer, machine learning scientist. Hopefully you don't need a PhD to understand that, though most people seem to say you do. And sometimes interoperability and reproducibility is a bit of a problem because much of this software was designed in isolation, maybe in an academic lab, maybe in a corporate research lab. And I think most importantly, I'm not at least seeing a lot of conversation asking what are the real technical needs from industries. I mean, we certainly talk a lot about self-driving cars, we talk a lot about chatbots, we talk a lot about image and video processing, natural language processing, but I'm not seeing a lot of people stop to really go out to, say, a person that's making all pipelines, go out to a person that's making water heaters and ask, okay, what do I really want to do over here? So I think that's a question, that's a conversation that needs to happen. I'm going to finish my talk by just saying a little bit about what my company does. What we are in space of is really virtualizing hardware and trying to ubiquitize AI to try to enable this as an industrial process, a standardized industrial process for enterprises. We do that by basically taking over the middle layer here. That's all the part between data task, platform, and hardware. And with that, that's really all I came here today to say. Thank you very much, and I'll take questions. Okay, thank you. Yes?
Give us an example of how a customer has used this platform.
Okay, so the question was give us an example of how the customer has used the platform. So, a little bit about the history of our company. We are about 9 months old right now, and so we do have some customers that are using parts of the platform to accomplish the solution, but I think I see this task as really a development task that's going to run for at least another year, if not more, to really cover all the space. I never said it was simple, basically. But I'll tell you what I envision the customer doing. When they're able to take this product, I do expect them to not require a data scientist. I do expect them to not require a machine learning engineer. I should be able to hand it to someone who doesn't even know what a configuration file or a command line or C or Linux or Python is. We really want it to be something that's very akin to what you expect from Mac OS, what you expect from iOS or Windows. That it should be at a level where you don't have to understand what's going on and all the sophistication is hidden away, because only then, I think, can you actually see standardized adoption. It has to be at a level where we're no longer requiring extremely highly trained, highly specialized people to do it. So that's one thing I want to say. And I think the other thing I want to say about how I imagine people using this is that initially, I think it will be that most of these organizations are trying to find what AI and ML does for their organization. So I'm not claiming that I have the answer for these companies, but I am claiming that they do want to explore themselves. They do want a platform that allows them to explore and find their own solution. And to do that, they need a platform that they can experiment with easily, but that doesn't require them to, how should I put it? I think an example I can give is that we've had conversations with folks that say, well, you know, I have 50 data scientists, but I have 1,000 business analysts, I have 1,000 MBAs. The MBAs do no programming, so what are they going to do about this? I think that's their target audience.
Thank you.